So next we're going to talk about using the limit definition to find the area under a curve. So it says, let f be a continuous, non-negative function on the interval a to b. The area of the region bounded by the graph of f, the x-axis, and the vertical lines x equals a and x equals b is the limit as n approaches infinity of the sum from I equals 1 to n of f of c sub I delta x, where c sub I is somewhere in between x sub I minus 1 and x sub I, or the left endpoint and the right point, and delta x is still b minus a over n. Let's go ahead and draw what that looks like. So let's just talk about our interval here from a to b. Let's pick b out here. So we're going from this point over here to this line. Okay, and we're just going to say that this would be x sub I minus 1, and then this right here would be x sub I, and we just need to let c sub I be somewhere in between here. And then our rectangle would actually look like this, okay, where delta x is still the difference here in our interval. Now it turns out that this height then would become f of c sub I. Okay, and you can see that right here. Okay, so that whole limit process is going to come in handy when we're finding the area under the curve. Okay, so let's take a look at our first example. It says find the area under the graph of f of x equals x cubed on our interval 0 to 1. So you can see our graph there. And so we're going from 0 all the way up to 1. So I'll draw that in. And we're going to have a couple intervals here. And notice there's going to be an infinite amount of intervals as we go along. And if I just let this be my interval, I can let c sub I be my right endpoint. So here's c sub I. Here would be f of c sub I. And then delta x is going to be still right in here. So there's our delta x. Okay, so when we go to solve this problem, the first thing we need to do is find what delta x is. So delta x is going to equal 1 minus 0 over n. Which in this case turns out to be 1 over n. Now we already talked about using our right endpoints. Okay, and so when we look at this, c sub I is going to equal, well, our starting point is at 0, and then plus I times delta x, or 1 over n. Okay, so our c sub I is really just going to be I over n. All right, now it's kind of weird because c sub I we had said was between x sub I and x sub I minus 1, but we really can just use the right endpoints. Make it a little bit easier on us. Alright, so next we want to focus in on the area. And this is going to equal the limit as n goes to infinity of the sum of I equals 1 to n of f of c sub I. So our function was x cubed, and c sub I is I over n, so that's just going to be I over n cubed. And that's going to give me the height of my rectangle, and then times delta x, which is 1 over n. Okay, so we just have to find this limit, and that is going to give us our area. Okay, so this is going to be the limit as n goes to infinity of the sum of I equals 1 going to n of, well, let's go ahead and cube that, so I cubed over n cubed. Then we still have times 1 over n. And let's just bring it back over here now. So it equals the limit as n goes to infinity of the sum of I equals 1 to n, and let's go ahead and distribute that 1 over n, so we get I cubed over n to the 4th. Okay, and let's go ahead and evaluate that formula for the sum. So it'll be the limit as n goes to infinity 1 over n to the 4th times I cubed turns into n to the 4th plus 2n cubed plus n squared all over 4. And when we look at this, the exponents are the same. So that means we need to divide coefficients, and so this is going to be 1/4. And that's going to be our final answer there. So when we look at the area bounded by this curve, the x-axis, and the two lines, all this area is going to add up to be 1/4. And it's kind of interesting. If we look, here would be a square, and that would equal 1. And it's kind of weird that that turns out to be 1/4 of the entire square right there. All right, so that's your process of using the limit definition to find the area under the curve. All right, I want you to go ahead and try the next example on your own. Follow the same process there. And I'd go ahead and use right endpoints again, but draw out your picture and find the limit of your sum to get your area. Go ahead and pause the video and come on back when you're done to check your work. All right, welcome back. So go ahead and check your drawing here. And notice I used c sub I, my right end points. So it was 1 plus I over n. And we found that delta x was 1 over n again. Here I have my formula written out there. Here you can see I substituted in my 1 plus I over n into my function, 4 minus x squared. And I have my delta x there. And I went ahead and squared that binomial in this step. In this step here, I just did the 4 minus the 1 right here. And here I showed a little bit more work than I did in the example. What I did is separated this out. I distributed the 1 over n to all three terms, and then showed that it was the sum of each of those separately. Again, you could skip that step, but now I can see that I have the sum of a constant, which is just going to be that constant times n. Here you can see I have the sum of I, so that one's going to be n squared plus n over 2. Here you can see I have the sum of I squared, and that's going to be 2n cubed plus 3n squared plus n over 6. And then you can see all of the constants just follow along right out in front there. Okay, then I still have that limit tagging along there. Then I went ahead and simplified a little bit, so 1 over n times 3n is just 3. And here I just multiplied these together. Again, I'm showing a little more work than what's necessary. And then here I showed the multiplications right here. Okay, from there you can use Bobo-Bot needs DC. Well, this is already a constant, so that if n changes, it's still going to be 3. So we get 3 there. Here the exponents are the same. Okay, you can see the 2 and the 2 are the same. And so this is going to be negative 1. Here the exponents are the same again. And so we have negative 2 over 6, or negative 1/3. And I just did a common denominator to add these up. We get an area here of 5/3. Okay, so again, the area under this curve bounded by line x equals 1, x equals 2, and the x-axis is going to be equal to 5/3.